But the first is designing experiments. So this is, again, asking the right questions. And this is actually a very difficult problem. Naively, you might say, well, I'm doing a machine learning model, so I just want the model with the highest accuracy. But if you're doing a real world application, you might want to trade off that accuracy for inference time. And maybe it's not actually accuracy you care about. Maybe it's some complex combination of precision and recall. Maybe it's not actually quite just that, but there's specific subclasses that you need a threshold on to make sure you don't drop below a certain accuracy. But then you want the larger profit to be expanded, all while, again, keeping maybe inference time or memory footprint within a specific size so that you can actually deploy this in production. And all of a sudden, a simple question of like, I just want the best model, what's the best model, becomes this much more complex problem. But even designing the right questions to ask is a big part of this process. Exploration is about understanding, and better understanding leads to better questions that you can ask, but it requires you to keep track of everything, be able to analyze everything, see trade-offs, patterns, and ultimately take that experimentation, that high dimensional optimization out of your head and into a tool that allows you to get the most out of every hour you've spent and the cluster is spent to get these results and really get you to the best possible next step. Finally, optimization is about once you've phrased a problem in a specific way, how do you get to the best version of your model that satisfies that problem as efficiently as possible? So in as few computational cycles, as few back and forth trips, as few different configurations tried, you want to maximize a few metrics, have constraints on a few metrics, thresholds on a few metrics, et cetera, and ultimately get to a model or a collection of models that you can then put into production.